Today we're going to take a look at operations with rational expressions. And remember, a rational expression is simply a fraction. So today we're going to add, subtract, multiply, and divide fractions. But the thing about fractions is, if you remember how to do those, if we have fractions of 3/4 times 3/8 or 9ths or whatever, don't you multiply top times top and bottom times bottom? So multiplying is actually easier in fractions than adding and subtracting. So I know in elementary school you started with adding and subtracting, but now that we're working with these big expressions, we're going to start with multiplying because that's easier. And I wanted to just show you a sample. For example, if this was a 9 out of 8, you make that a 9, so that I can show you the canceling bit. Isn't this 3 times 3 over 2 times 2 times 3 times 3? And isn't it true that if you have 1, that they cancel? So there are 2 1s. So this fraction is really just 1/4, because this cancels as a 1 and a 1 and a 1 and a 1, doesn't it? Okay? So if you've not learned how to cancel with fractions, this might be a little more difficult for you to imagine, but that's what we're going to do. We're going to factor each piece till its prime form, which is why we had to do factoring first. And then we're going to see what's left. Okay? So if you take a look at this first example that I have selected, x minus 2 is prime. You can't factor that anymore, but we can factor this portion. And the 2 times x plus 3 is how you would factor that. Okay? This is really multiplying, but you see now I'm going to write this as one fraction bar. This piece factors as 3 times x plus 9. I'm sorry, x plus 3. And this piece factors as 2 times x minus 2. Now, that just looks like a whole bunch of stuff, but what happens if I rearrange these a little bit? Now, I'm rearranging these so that you can see the ones that I'm going to take out. Many of you can take out the ones from this step and you won't need to rewrite it. But we know that multiplication is commutative, so I'm going to write the x minus 2 on the top, and I'm going to write this x minus 2 underneath it. Okay? So those are still factors. And again, multiplication is commutative, so I can rearrange these pieces. So I've used this and I've used this. Now times the 2, and I'm going to take this 2 and put it here, so it's easy to see. And then times the x plus 3. So all I've done really is to rearrange the bottom. And all I've not used down there is the 3. So I've used the commutative property for multiplication just to rearrange these. Now the thing that I want to point out, again, many of you don't have to rearrange these. You're able to do this without thinking about it. But isn't x minus 2 over x minus 2 equal to 1? And isn't 2 over 2 equal to 1? And isn't x plus 3 over x plus 3 equal to 1? So really, and it doesn't look like we've done any multiplication, but we have. The answer to this is 1/3. And so this piece right here simplifies to be 1/3. So in this problem, again, although it says multiply, we're going to factor. I'm going to factor the top. This is a difference of squares, so this piece right here is going to factor into x minus 3, x plus 3. This piece is going to factor into x times x minus 3. X squared is x times x. And this one, this trinomial here, is going to factor into x plus 4 and x minus 3. And I use the guess and check strategy, but if you're stuck on that, you can mark or use the lattice or the x or some way to factor that trinomial. But pretty much what happens, and I'm not going to rearrange them this time. I think we kind of get the idea. X minus 3 over x minus 3 is 1. X over x is 1. And so what I'm left with is x plus 3, x minus 3, over x times x plus 4. And I do want you to leave your answers factored. Don't multiply them back out. Okay, when you leave your answers factored, you can see that there are no other things to cancel out. Top times the top and the bottom times the bottom. So we're going to factor these, even though it says multiply. We know that when we multiply fractions, we can take out the ones. So we're going to factor x squared minus 5x plus 6. And so that would be x minus 2 and x minus 3. I know there's a couple of ways you can get 6, but always kind of go back and think about this being negative 5 when you multiply these two, and this being this being negative 2 and this being negative 3. So they add to give you 5, and negative times a negative is a positive. So that does kind of check out for you. So make sure that you have factored that correctly. This side is a difference of squares. So it's x minus 1 and x plus 1. And now we're going to work on the bottom. So this piece is going to factor as x minus 3 and x plus 1. And again, you can FOIL those two to make sure that you factor that correctly. And finally, this last piece is x minus 2x plus 2. So we can cancel out our 1s. The x minus 3 cancels with the x minus 3. The x plus 1 cancels with the x plus 1. The x minus 2 with the x minus 2. And you can see what we have left is our answer. So this does look a bit simpler and more believable than the last answer that we got, which turned out just to be a number. Okay? So when we multiply this trinomial over another trinomial by a binomial over a binomial, a lot of things kind of simplify out, don't they? So multiplying those gives you a simple answer. Now let's talk about division. When you divide fractions, you multiply by the reciprocal. So that means you turn the second one, always the second one, upside down. So as I factor this, I'm going to put x squared plus 8x plus 15 on the top and x squared plus 5x plus 6 on the bottom, and change this to multiplication. Because when we divide fractions, we multiply by the reciprocal. So all I've done so far is to rewrite the problem. Okay? You can pause it here if you need to take a closer look, or pause it here if you want to try and factor it now. All right, hopefully you factored this as x plus 2, x minus 2. And the top of this one as x plus 5, x plus 3. And on the bottom, this one would be x plus 5, x minus 2. Because positive 5 and negative 2 give you the 3. And a positive times a negative is going to give me the negative 10. So finally, on this one, we could do 6 and 1, but that would be subtraction, and there's no subtraction in this problem. So we're going to use the other factors, the 2 and 3. So this would be x plus 3 and x plus 2. And now you can see that we have a few 1s to cancel out. So x plus 2 over x plus 2 gives me 1. X minus 2 over x minus 2 gives me 1. X plus 5 over x plus 5 Oh my goodness, what's happening here? The answer is not 0, like many people think, but 1. Because when you cancel these out, this all becomes 1s. And so the answer is 1 when everything cancels out for multiplication. If everything cancels out for addition, it's 0. But if everything cancels out for multiplication, it's 1. And I'm going to put this on the table. What are we doing here? This problem is not multiplying, is not dividing, but is adding. Okay? So we know when we add or subtract fractions that we have to find a common denominator. Okay, we're lucky in this problem because the common denominator is there, isn't it? So let's just do kind of a little side bubble over here. If I have 3/5 plus 1/5, don't I add the tops and keep the bottom? So that's exactly what we're going to do when we have this. We're going to add the tops and keep the bottom. 6x plus 5 is my denominator because they're the same. I can put the numerators, the things that are alike, together. So isn't 4x plus 8x equal to 12x? And isn't 1 plus 9 equal to 10? So some of you aren't going to do this middle step, and I'm perfectly all right with that, but I wanted to write it down for you to have in your notes or for you to kind of go back and rethink what you're doing. Now you need to do exactly what you did in the last one, and that is see if you can factor. Can we factor the top in 2 times 6 plus x plus 5? And then what happens? The 6x plus 5 cancel as 1, and so my answer for this problem is 2. Right? Okay, now we're going to look at different denominators. So to talk about different denominators, again, to talk about different denominators, what if we have something like 1/3 plus 1/5? Don't we, if they have no common factors, just multiply the bottoms to find the least common multiple? These have no common factor, right? So the LCM is their product. We're 3 times 5, correct? So then you ask yourself, okay, I multiplied this one by 5/5 because I can multiply by 1. That's the added, the multiplicative identity. When I multiply by 1, I haven't changed the value of that, but that becomes a 5. This one I need to multiply by 3/3. So 5 times 3 is the same as 3 times 5, and 1 times 3 is 3. So now, once I have the common denominator, I simply add the top, so get 8/15. We're going to do exactly the same thing with these. It's going to look a little different, a little more complex because of the bottoms, but it is the same exact steps. So if you can recall those steps, you can recall them here too. Okay? So these are prime. This is prime. You can't factor those. You need to factor them first to see if there's any common factors. So if there weren't any common factors, the least common multiple was the product. The least common multiple is the denominator. So the denominator, the LCD for this, is the product of these two things. So far, so good? Now, I need to do the next step that we did, which is write equivalent fractions. Okay? Writing equivalent fractions, I'm going to ask myself, okay, what did I do to this to get this denominator? Didn't I multiply x plus 4 times x plus 5? So I'm going to do the same thing. I'm going to multiply this by 1, x plus 5 over x plus 5. now 1. And then that's going to be my new numerator. Okay? What did I multiply this one by to get the new denominator? X plus 4 over x plus 4. So this now becomes 6 times x plus 4. Okay? So, the denominators, or the LCM, kind of cheat there. It's hard to write in that. You can cheat it. Okay? As long as you know what the LCM is, you put that in your final answer, you can show that in your work. Okay? So 3 times x is 3x, and 3 times 5 is 15. And the plus sign, remember when the bottoms are the same, you're just going to add the tops. So this is 6x plus 24. Now I'm going to put like terms together. So this is going to be 9x plus 15 and 24. Gosh, help me out with that. What is it, 39? Did I add that right? Now I can factor the top. 3 goes into both of them, right? But it didn't do me any good because you can't cancel anything.